Hello and welcome to the screencast on Getting to Know Packet Tracer. Packet Tracer simulation software can be used to teach complex CCNA level networking concepts and to supplement classroom equipment. With Packet Tracer, instructors and students can design, build, configure, and troubleshoot networks using virtual equipment. Packet Tracer provides a simulation and visualization environment with continuous real-time updates of underlying network logic and activity. It provides a common environment for instructors to demonstrate technologies and configurations, making it extremely useful for lectures, group and individual labs, homework, and competitions. Students use Packet Tracer to explore concepts, conduct experiments, and test their understanding. In this demonstration, we will use the most basic features of Packet Tracer. Like many software programs, Packet Tracer has many more features than you might want to use at first. But just like you could use Microsoft Word to do very basic word processing, you can use Packet Tracer to configure very basic networks. Let's begin by first installing Packet Tracer. In order to install Packet Tracer, we must first log on to Cisco Academy Connection and download the installation package. To access the Cisco Academy Connection, point your favorite web browser to cisco.netacad.net. Remember to log on to the Academy Connection part of the website. Enter your login credentials you created the first time you visit this site. My login credentials would be nandre03 and my password ... Click on the photo link of Cisco Packet Tracer found on the left navigation menu. This portal contains helpful resources when it comes to Packet Tracer. Somewhere on this page you will find the Packet Tracer program downloads link. Click on this link. Somewhere on this page you will find Packet Tracer 45.3.3 application only. Click on exe-49 megabytes. After the installation package downloads, we can begin the next part of the screencast. As mentioned earlier, Packet Tracer is a great tool to learn and demonstrate. Region 1 of this diagram illustrates the menu area. In the menu area, you will find basic commands such as open, save, save as, pkz, print, and preferences. Area 2 represents the main toolbar. Area 3 would represent the common tools bar. Area 4, the logic/physical workspace switch. Area 5, the workspace. This area is where you will create your network, watch simulations, and view many kinds of information and stats. Area 6 is the real-time/simulation switch. Area 7 is the network component box. This box is where you choose devices and connections to put in the workspace. Area 8 is known as the device type selection box. Area 9 is its sister box, known as the device specification box. Area 10, we will probably not use this semester, is known as the user created packet window. Let's take a closer look at the first major area, the main toolbar. This bar provides shortcut icons to the File and Edit menu commands. This bar also provides buttons for copy, paste, undo, redo, zoom, and the drawing palette. On the right you will also find Network Information button, which you can use to enter in a description of the current network. The area to the right is known as the Common Toolbar. This bar provides access to these commonly used workspace tools, such as Select, Move, Layout, Place Note, Delete, Inspect, Resize Shape, Add Simple PDU, and Add Complex PDU. The most important area in Packet Tracer is known as the Network Component box. This box is where you choose devices and connections to put into the workspace. It contains the device type selection box and the device specific selection box. The contents in the device specific selection box will change according to what the device type the user selected in the device type selection box. In this example, I selected End Device Type to display the types of end devices available in Packet Tracer, such as a PC, a laptop, a server, a printer, or an IP phone. As you can see, there are other types of network components the user can pick from. We will go over these components as the course progresses. We will also cover other areas like the logical/physical workspace and the real-time/simulation bar and other screencasts. For now, I would like to go over how to create and arrange devices. This topology will allow students to practice configuring a PC to participate on the network. Students may be directed to choose their own network or may use a network defined by the instructor. These basic exercises will also help students to develop good documentation skills, such as labeling their equipment and networks. Since each student can have a copy of Packet Tracer to take home, students can practice what they've learned outside the classroom. This additional practice helps students to build confidence and to accurately assess what they do and do not understand. The large white space that opens by default is the workspace where you will create your topology. You can use the entire workspace and can even scroll down and to the right to utilize a larger area. Since our topology is very small, we will use only the left part of the screen. This will help us with workspace later when we are running a simulation. To create a device, first click the selection tool. Second, choose a device type. Third, choose the device you would like to add. And finally, click on the workspace where you'd like to add the device. Here are a few tips to help you get started. If you'd like to create multiple instances of the same device, hold down the Control key before selecting the device. After selecting the device, let go of the Control key, then click in the workspace above. Each time you click will add a new device on the workspace. To cancel this process, simply press the Escape key. Devices can also be dragged to new locations by first selecting them, holding down, and moving around. Finally, letting go by simply letting the left mouse button. A multiple selection can be used to delete items, to move items, to copy items, or to cut items. Instead of using the horizontal and vertical scroll bars, use the Move Layout tool. And a final note, at any point you can save your topology using the Save button on the toolbar or the Save command from the File menu. Be sure to save often and save it as a PKT, Packet Tracer file. Now that we added a few components, let's talk about connecting these devices together. The easiest way to connect two devices in the workspace is to use the Smart Connection tool down in the bottom area. To select the Smart Connection tool, first click the Select tool. Second, choose the connection icon that looks like a lightning bird. Third, choose the Smart Connection tool that looks like a lightning bolt as well. But this time it's in the device specific area, not the selection area. Fourth, click on the first device you would like the cable to connect to. Fifth, click on the other device. Now that the cables are connected together, you may notice that the links between the switch and the router are down. They're indicated by red dots, but the link between the PC and the switch is up, giving you an indication of green. This is because the fast Ethernet interface on the router is shut down, whereas both interfaces on the switch and the PC are up. Because the interfaces are in the up position, they're operational and are indicated quickly by using colors like red and green. If one port is turned off, whether on the PC or the switch, then both ends of the cable will go red. To find out what port each wire or cable is connected to, take your mouse and hover over the red dot or the green dot. When using the Smart Connection, you may need to mouse over this to determine where exactly the problem lies. Once we have connected all of our components in our network, we can go into configuring each device. To configure a PC, we must first click on the PC. Once we click on the PC, a new dialog box should appear. Click on the Config tab and then click on the device name. It's always a good idea to give each component in your topology some verbal description. Remember, no two devices can share the same name in Packet Tracer, just like no two devices on the same network can share the same name. The most important piece of information that each component on a network must be configured with is some type of addressing scheme. To configure a PC's IP address, you must first select the PC, then click on the Configuration tab, then on the left side select the Fast Ethernet link to configure the IP address and the subnet mask. The default subnet mask will be filled in automatically when you tab from the IP address field to the subnet mask field. Note the bandwidth and duplex can be set to auto to simplify configurations when you're first learning how to network computers using Packet Tracer. Another important tool in Packet Tracer is called the Add Notes tool. If you are trying to communicate a problem to your instructor, or you need a personal note to let you know where you last left off when you're configuring your network, the Add tool can help you remember this or help indicate to your instructor where exactly a problem happens. To add a note next to a device, first click on the Note tool, then click near the device you want to bring out some reminder or helpful hint, then start typing. It's always important to save your work frequently as you are modifying and changing your devices. It's also equally important to save your work right before you submit your file to your instructor. One of the easiest ways to accomplish this is simply click on File and choose Save. I prefer to choose Save As. This way I know where the file is being saved to. The Save As dialog box is no different than the Save As dialog box in Windows, Word, Paintbrush, or any other Windows program. Some tips to remember when you're saving your work. Router configurations are lost if they are not saved before the router is powered off. PC configurations are saved automatically. What I mean is, when you change an IP address in a PC, after you change it, Packet Tracer automatically saves it. This does not mean it will save the creation of a PC or the removal of a PC. I save frequently. I hold the control key and hit the letter S every time when I get done doing a simple task. Packet tracer files are saved with a .pkt ending. You can save the files anywhere on your computer or your network. Once the files are saved, they can be reopened and contain all device and configuration files you have created the last time the file was open. Now that all of our work is done and we have created our topology, the last thing when creating a network is to verify that that network works. There are several ways to verify connectivity in Packet Tracer. In real-time mode, open a command prompt from the PC desktop and issue a ping just as you would in the classroom with real equipment. In simulation mode, create a simulation that allows you to open up the packet at different points along the path to view how the device is processing the packet. To verify in real-time mode, make sure in the lower right corner the clock is shown and underneath the clock it says real-time. Then click on the PC in the workspace to open up the PC option window. Select the desktop tab and then choose command prompt. From the command prompt, issue the ping command followed by the IP address of the device you would like to verify. Remember that this is real-time mode, so packets are processed in real time, just as they are using real equipment. In this screencast, I demonstrated to the student how to download and install Packet Tracer, how to create and arrange devices in the workspace, how to connect these devices together, how to configure these devices so they are on the same logical network, and how to verify that our configuration was properly done.